This is lesson 6.4, the quadratic formula. In this lesson, we're going to learn how to use a quadratic formula to solve quadratic equations that you cannot factor. So far we learned how to find the zeros or the roots or the solutions to quadratic relations by factoring. So we'll do an example together here. So let's get our ink ready to go. We're going to try to solve for A. For question A using our factoring method. So we have 0, and I'm going to go through this one quickly because you already know how to factor, and if you don't, you can go back and take a look at our video lessons. Open your brackets up here, find a product that's equal to two numbers whose product gives you 6, and when you add them up gives you 5. So 2 and 3 seem to work there, so x plus 2, x plus 3, and then you can just figure out when this whole thing would be equal to 0, which is when x plus 2 is equal to 0. So that means x must be equal to -2, or when x plus 3 is equal to 0, which means that x is equal to -3. So our zeros are -2 and -3 here. And that was by the factoring method. And if you take a look at this one here, you can probably try the same approach. So you can do, equals to 0 here. So you can try to factor, open your brackets up, put your 0 here, put your x here, and you'll notice that if you try to find two numbers whose product gives you 5 and when you add them up gives you -3, you can think about that for a long time. You probably won't find those two numbers. So this one here would be one of those examples of a non-factorable quadratic expression. Sometimes, you can try as hard as you want. Sometimes it is impossible to solve by factoring. Sometimes you can't find those two numbers that give you the product of this and some of that. So in that case, you'll have to use what's called the quadratic formula or equation. Quadratic equation or formula. You can actually use a quadratic equation even when it is factorable. What I recommend is that when we learn it, you go back and try some from your previous homework and see if you get the same answers. So it's a great way to check your work. So let's take a look at how the quadratic equation or formula looks like, and we'll see what all the different parts mean. So first of all, I want to point out that you need to be in your standard form if you want to use the quadratic equation. So here's our standard form. And our quadratic equation is written this way. X, for our solution or our root or our zeros, is equal to the -b plus or minus square root of b squared minus 4ac all over 2a. And so these variables stand for the variables that are in the standard form here. So you always want to make sure when you're using the formula that you put your relation in its standard form. And the reason you want it in your standard form is so you can find the values of a, b, and c. So for example, the a is the number in front of the coefficient in front of your x squared, the b is a coefficient in front of your x, and the c is a constant. That includes the signs as well. And now what you actually have here is two formulas. You have x is equal to -b plus square root of b squared minus 4ac over 2a, or, and you'll use the other one as well, -b minus square root of b squared minus 4ac over 2a. So you kind of do both at the same time because you might have two zeros. So basically what you do is you substitute your numbers for the variables in the equation, and then you solve and you can find what your zeros are. Now, one thing I want to point out is that you may not always have two zeros. Your parabola may not hit the x-axis twice. Sometimes you might not even hit it at all. You could have 0 solutions, you could have 1 solution, or 2 solutions. So an example of 0 solutions would be something like this, where you have your parabola that's maybe above the x-axis and opens upwards, and it just keeps going up. It's never going to hit the x-axis. Same thing with this one over here. Where this one over here, it opens from the bottom and it's below the x-axis and just keeps going down. So in this case, you'd have 0 solutions, and we'll see what that looks like using the quadratic equation later on. You might also have 1 solution, and so that one would be something like this, where the parabola hits, whoops, that was 2 solutions by accident. Let's erase that quickly to show you what 1 solution properly looks like. So if you have 1 solution, you might have something like this. The parabola's vertex hits the x-axis, and it just hits really at that one spot, the vertex area there. So this would be 1 solution. Or you might have two solutions where the parabola actually goes through the x-axis twice. So one of those typical examples that we've seen like this before, or like this. So this would be having two solutions or two roots or two zeros, so to speak. So it's either one of these possibilities, cases is possible. We're going to see how we can interpret that using our quadratic equation going forward. So we're going to solve some of these together using the quadratic equation. You could try solving by factoring if it is factorable, but if not, we can use our quadratic formula. And also do what the question asks. So in this case, we're solving using the quadratic formula. So let's first of all find our a, b, and c values. So our a value over here is going to be the number in front of the x squared. It's 3, this one here. Our b value is the number in front of the x, which is really, if there's nothing there, it's a 1. You have to make sure you put the proper sign, so they're all positive in this case. And our c values are constant, so -2. So let's write out our quadratic formula. We have x is equal to minus b plus or minus square root of b squared minus 4ac. Make sure that's all in the square root there. All over 2a. And so now we're going to go and plug in our numbers. So we have x is equal to minus b, so minus 1 plus or minus square root of minus 1 squared minus 4 times a, which is 3, times c, which is -2. Make sure you extend that root there. All over 2 times a, which is 3 there. And now we can go and clean it up and simplify a little bit. So this is equal to, so x is equal to -1 plus or minus square root of, so -1 squared is 1, minus 4 times 3 is 12, minus 12 times minus 2 is 24, so plus 24, all over 6. And then that gives us x is equal to minus 1 plus or minus square root of 25, all over 6. And that will give us x is equal to minus 1 plus or minus 5, all over 6. And so now we can go two paths. We can choose the plus path and the minus path. And so we'll do that here. So we'll do the plus path on this side. So we get x is equal to minus 1 plus 5 over 6. And so that will give us x is equal to minus 4 over 6. Let me just carry this out here since I'm running out of space. So x is equal to, minus 4 over 6, or plus 4 over 6, sorry, plus 4 over 6, which is 2/3. So our first solution is 2/3. And then the other path we could have taken, so this way here, is the minus 1 minus 5 path over 6. X is equal to, which would give us x is equal to minus 6 over 6, which means that we have -1. So our solutions are x is equal to -1, and also x is equal to 2/3. So here we have a case where we have two possible solutions. So we have two possible solutions in this case over here. And so the idea is you set it up so that you get to this point here, and then afterwards you branch off and you try this, and then you go different paths, your plus or minus paths, so you can see what your solutions are overall. So this is a case where we have two solutions that are possible, and again, if you can factor, try it out, factor it, but if you can't factor it, then use your quadratic formula. You need to be able to do both skills. So we're going to try another example together. We're going to try this example here where things may not look as neat and clean, but we'll try it out. So again, same idea, find your a, b, and c values. So your a is 1 in this case. Your b is -6. And your c is 4. And so what you're going to do is you're going to write out your formula again. It's over here, so I'm not going to rewrite it. You can rewrite it though. You should be rewriting it every single time. So I'm going to write that x is equal to minus b, so minus 6 plus or minus square root of b squared, so minus 6 squared, minus 4 times 1 times 4, because it's AC. I'm going to then put this all over 2a, so 2 times 1, and continue to clean this up a bit. So we're going to get minus 6 gives us 6, so be careful with that because people often make that mistake here with the signs. Plus or minus square root of 36, because that's negative 6 squared, minus 4 times 1 times 4, so minus 16, over 2. And so when you clean that up, you get x is equal to 6 plus or minus square root of 30 over 2. And now we can go, so you'll notice that it's not a nice root like we had before. We could do square root of 25 gives you 5. Now we can't really do square root of 30 here to give us that nice round number there. So we're going to have to proceed with this method anyways. So we're going to do our positive one on this side or negative one on the other side. So we'll go x is equal to 6 plus root 30, square root of 30, square root 30 over 2. And if you put that in your calculator, you'll see you get x is equal to 5.24. And we can go the other route as well. X is equal to 6 minus square root of 30 all over 2, because 2 times 1 is 2. And we would get, if you put that in your calculator, 0.76. We're rounding to 2 decimal places here. So this is a case where we have 2 roots still. We have one root being at 5.24 and one being at 0.76. In the cases where you'd have no roots or one root, you would notice you would have a square root of a negative number in there. So if you have a square root of a negative number, that would result in you not obtaining a root. You can't do a square root of a negative number, at least not in grade 10. There's ways around it later on, but in grade 10, if you see something like square root of negative 4, put that in your calculator, you'll see that it won't work. So go ahead and try that now. Just go in your calculator and do square root of negative 4 or negative 6 or whatever it is, and you'll see you'll get an error. So if you have a square root of a negative number, you're going to see that you won't have any real zeros. It'll be one of the 0 cases. In the other case, where you only have one root, you're going to see that both your roots will give you the same answer, essentially. So you might have both of them equal to 5.24. But when you see you have a negative in that square root area, you're going to have 0 roots, 0 zeros. In other words, no solution for that particular quadratic relation. So what we've seen is how to use the quadratic equation to solve for relations that may not be factorable, and you could use them for ones that are factorable. So make sure you know this formula and you know how to apply it. Make sure you know that you can have 0 roots if you have a negative square root in there, so a square root of a negative number, I should say. You can have 1 root if both your roots are the same answer in the end. We don't have that here, though. And you can have 2 roots if you have 2 different answers. So as you practice, you'll see these different possibilities throughout. In the next video, what we're going to do is we're going to do a sample problem that involves an application of this using the quadratic equation instead of the factoring method.